Hey guys, Game Dev Coach here. Welcome to my channel. In this video, we'll be diving deeper into finite state machines and how to implement a simple finite state machine in Unity. If you are new here, then consider subscribing because I release weekly videos and you don't want to miss out on them. Also give this video a like and comment because it helps get my channel out there so that more people can discover it. So without further much ado, let's get into the video. Hey, real quick, before we get started, I just want you to take a second and hit the subscribe button and turn on post notifications. Nice, you did it. Let's get back into the video. Before we get our hands dirty, let's take a look at the video overview. In this video, we'll expand our knowledge of the FSM pattern and its uses in games and learn how to implement it in a simple tank game in Unity. We'll be dissecting the code and the components in this project. The topics we'll cover are as follows: understanding Unity state machine features, creating our own states and transitions, creating a simple scene that will implement an FSM. Unity 5 introduced state machine behaviors, which are a generic expansion of the mechanism animation states that were introduced in the Unity 4 versions. These new state machine behaviors, however, are independent of the animation system, and we will learn how to leverage these new features to quickly implement a state-based AI system. In our game, the player will be able to control a tank. The enemy tanks will be moving around in the scene with reference to waypoints. Once the player tank enters their visible range, they will start chasing it, and once they are close enough to attack, they will start shooting at the tank agent. This simple example will be a fun way to get our feet wet in the world of AI and finite state machines. Finding uses for finite state machines. Although we will primarily focus on using finite state machines to implement AI in our game to make it more fun and interesting, it is important to point out that FSMs are widely used throughout game and software design and programming. In fact, the system in Unity that we'll be using was first introduced in the mechanism animation system. We can categorize many things into states in our daily lives. The most effective patterns in programming are those that mimic the simplicity of real-life designs, and FSMs are no different. Take a look around and you most likely notice a number of things in one of any number of possible states. For example, is there a light bulb nearby? The light bulb can be in one of two states, on or off, so long as you are not talking about one of those fancy dimming lights. Let's go back to grade school for a moment and think about the time when we were learning about the different states matter can be in. Water, for example, can be solid, liquid, or gas, just as in the finite state machine pattern in programming, where variables can trigger a state change. Water's transition from one state to another is caused by heat. Though there are no hard rules beyond those of our own implementation in programming design patterns, it is a characteristic of FSMs to be in one and only one state at a given time. With that said, transitions allow for a handoff of sorts between two states, just like ice slowly melts into water. Additionally, an agent can have multiple FSMs, driving any number of behaviors, and states can even contain sub-states of their own. Think Christopher Nolan's Inception, but with state machines instead of dreams. There are many different implementations and variants of the finite state machine in C# and Unity, many of which can be found in the Unity Asset Store, but they share a few features. They define the various states that an object can be in. They provide a mechanism for transitioning from one state to another. They provide a way to define the rules that govern transitions. Unity's mechanism system, though intended originally for driving animations in a state-based manner, fits the bill quite well, as it provides a lesser known, more generic set of FSM features. Okay, so now that you are familiar with the concept of state machine, let's get our hands dirty and start implementing our very own. As of now, state machines are still part of the animation system, but don't worry. They are flexible and no animations are actually required to implement them. Don't be alarmed or confused if you see code referencing the animator component or the animation controller asset, as it's merely a quirk of the current implementation. It's possible that Unity will address this in a later version, but the concepts will likely not change. Let's fire up Unity, create a new project, and get to it. So first off, let's start by creating the animation controller asset. The animation controller asset is a type of asset within Unity that handles the states and transitions. It is in essence an FSM, but it also does much more. We'll focus on the FSM portion of its functionality. An animator controller can be created from the Assets menu. So go to the Assets menu, then you select Create, and then choose Animation Controller from the sub-menu that appears. And then we are pretty much done creating the animation controller. Once you create the animator controller, it will pop up in your project's assets folder, ready to be named. We'll name it Tank FSM. When you create the animation controller, unlike most other asset types, the hierarchy is blank. That is because animation controllers use their own window. You can simply click and open in the hierarchy to open up the animator window, or open it up in the window menu. Let's familiarize ourselves with this window before moving on. The first part we'll look at is the layers and the parameters. Layers, as the name implies, allows us to stack different state machine levels on top of each other. This panel allows us to organize the layers easily and have a visual representation. We will not be doing much in this panel for now, as it primarily relates to animation. Second, we have the parameters panel, which is far more relevant to our use of the animator controller. Parameters are variables that determine when to transition between states, and we can access them via scripts to drive our states. There are 4 types of parameters: float, int, bool, and trigger. You should already be familiar with the first 3, as they are primitive types in C#, but trigger is specific to the animator controller, not to be confused with physics triggers, which do not apply here. Triggers are just a means to trigger a transition between states explicitly. Here is a summary of the items depicted in the video. Search. We can quickly search through our parameters here. Simply type in the name and the list will populate with the search results. Add parameter. This button lets you add new parameters. When you click on it, you must select the parameter type. Parameter list. This is the list of parameters you've created. You can assign and view their values here. You can also reorder the parameters to your liking by dragging and dropping them in the correct order. This is merely for organization and does not affect functionality at all. Lastly, there's an eyeball icon which you can click to hide the layers and parameters panels altogether. When the panels are closed, you can still create new layers by clicking on the layers drop down and selecting create new layer. The animation controller inspector. The animation controller inspector is slightly different from the regular inspector found throughout Unity. While the regular inspector allows you to add components to the game objects, the animation controller inspector has a button labeled Add Behavior, which allows you to add the state machine behavior to it. This is the main distinction between the 2 types of inspectors. But apart from this, it will display the serialized information for any selected state, substate, transition, or blend tree, just as the regular inspector displays the data for the selected game object and its components. Behaviors are sly and tricky. Though their name might lead you to believe they are related to mono behavior, do not fall for it. If anything, these 2 are distant cousins at best. In fact, behaviors derive from scriptable objects, not mono behavior, so they exist only as assets, which cannot be placed in a scene or added as components to a game object. Okay guys, so I decided to cut the video into 2 parts, and this will be part 1 of the 2-part series. In our next part, we'll be looking at creating our very first state, transitioning between states, setting up our player tank, creating the enemy tank, choosing transitions, and many other stuff. So stay posted and make sure to turn on the post notification so you don't miss part 2 of this video. Thanks for watching. Peace.